In this video, I'm going to talk about linear equations and their graphs. The word linear is the adjective form of the word line. So linear equations are referring to equations of straight lines. When we talk about an equation of a straight line, most people will think about y equal to mx plus b, where m is referring to the slope and b is referring to the y-intercept. There are several important slopes that we must remember, and I'm going to illustrate with the program Desmos. When the slope m is equal to 1, then the corresponding straight line is at an angle 45 degrees upward from bottom left to top right. This is because when m equals to 1, then the equation becomes y equal to 1x plus b, or simply y equal to x plus b. So x and y move in a 1-to-1 ratio, and 45 degree exactly means that it bisects the 90-degree angle, right in the center between the x direction and the y direction. If the slope m is bigger than 1, then the slope gets steeper and steeper. The larger the slope, the steeper the line. Imagine if the slope gets to infinite, then we will get a vertical line at that moment. However, because infinite is not really a number, we would usually not say that the slope is infinite, but we will say that the slope is undefined. So please remember that undefined slope means a vertical line. If the slope goes the other way round and becomes less than 1, then the line becomes less steep than 45 degrees. As you can see, the line is now mildly increasing when the slope is between 0 and 1. If the slope goes to 0, then the line becomes completely flat. This is because when m is 0, then the equation will have no x, since 0 times x will make x disappear. So the equation becomes y equals to b. In other words, no matter how you change the x value, the corresponding value for y is always b. If the slope continues to decrease, then it will go negative. And when the slope is between 0 and -1, then it will be mildly decreasing from top left to bottom right. When the slope is -1, then once again the line will make an angle of 45 degrees with both the horizontal direction and the vertical direction. If the slope continues to decrease and go all the way to -infinite, then the line becomes vertical again. How about the y-intercept b? What b does is to control the intersection point between the line and the y-axis. Right now, b is set to be 5, and so the two lines will intersect at 5. If we change the b, then you can see that your new intersection is -6.4. So we now see how y equals to mx plus b controls the slope and the y-intercept, and we usually call this equation the slope-intercept form of the straight line. This form is quite useful and we like it a lot. However, there's one problem, namely that not every single straight line on the rectangular coordinate plane can be written in this manner. Which one can we not express it in this manner? Well, I have already given you the hint just now. When the slope is undefined, that means when m is quote-unquote infinite, then we cannot write it into y equals to mx plus b form. Rather, we have to write it out separately as x equals to a. Let's take a look at Desmos again. Do not try to plug in x equals to a directly into Desmos. Otherwise, decimals would think that this is the x-axis and this is the a-axis, and it would totally mess you up. Rather, you should try to plug in actual numbers into it. For example, -3. Then you can see that this is a vertical line intersecting the x-axis at -3, 0. If you change this number into 5, then this vertical line will shift over to intersect the x-axis at 5, 0. The equation x equals to a constant always represents vertical lines because no matter how y values fluctuate, the value of x stays the same. Now that we have seen the limitation of the slope-intercept form, is there any form that can represent all straight lines on the rectangular coordinate plane? The answer is yes. We can use the standard form, also known as the normal form. The word normal actually means perpendicular in mathematics. However, I'm not getting into details why it's called normal form, because you would need to know something about vectors before we can continue our discussion. The normal form of an equation of a straight line is given by ax plus by equals to c, where a and b cannot be both 0 at the same time. That means that it can be 0 for a but not 0 for b, or vice versa, but you just cannot have both of them being zeros. The reason we have to forbid this is because otherwise we will have 0 equal to c, which is not an equation at all. The normal form can describe any straight lines on the rectangular coordinate plane, regardless it is horizontal or vertical. If you're given an equation in the normal form, how can we graph the straight line? It is actually pretty easy. Let's take a look at the following example. To graph this equation, we should find out the x-intercept and the y-intercept of this equation. To find out the x-intercept, we should substitute y equals 0 because the y coordinates are always 0 on the x-axis. Substituting y equals 0, we are left with -4x equals to 10, and x would be equal to -2.5. As for the y-intercept, we should substitute x being 0 because the x-coordinates at this moment is always 0, and we are left with 5y equals to 10, so we have y equals to 2. Marking -2.5 and 2 on the x and y axis respectively, we can graph the straight line by joining the 2 points directly. There are two other very useful forms of a linear equation. The first one is called the point-slope form. Imagine that in a rectangular coordinate plane, you are given a point as well as a slope, which is a direction. Then the straight line is determined. How can we write down the equation of this straight line? We are going to use the point-slope form. It is given by y minus b equals to m times x minus a. You may ask, where does it come from? It is so random and difficult to memorize. It is actually pretty intuitive. For any point xy, if you want it to be on the straight line, then when you try to calculate the slope between AB and xy, it must be m. So we are going to apply the slope formula y minus b over x minus a must be equal to m. Multiplying the denominator over to the right hand side we'll obtain our point-slope form. Another useful form is called the two-point form. Once again, imagine that on the rectangular coordinate plane, you're given 2 points A1, B1 and A2, B2. Then there's a unique line that will pass through these 2 points. How can we write down the equation directly? We are going to use the two-point form. It is given by the following. Y minus B2, it is equal to B1 minus B2 divided by A1 minus A2 times x minus A2. This looks crazily complicated, isn't it? But no, if you try to look back at the point-slope form, you will recognize that we are simply replacing the slope m by the slope formula between A1b1 and A2b2. So essentially, the two-point form is not a new formula, but just an application of the point-slope form. However, it is readily usable to write down the equation of a straight line that passes through any 2 points on the rectangular coordinate plane, unless those 2 points are vertically on top of each other. Finally, before I end this video, I would like to remind you that if we have 2 straight lines that are parallel to each other, then the slope m1 and m2 will be equal to each other. However, if the 2 lines that we have are perpendicular to each other, then the 2 slopes m1 and m2 will multiply to form -1. Or we can say that they are negative reciprocal of each other. Thank you very much for watching. If you like this video, please subscribe to our channel and we will learn more fun math together. Thank you.